Hello, everybody. Okay, so we're looking at now proving de Moivre's theorem by proof by induction. So recall de Moivre's theorem is just when I have a complex number here in polar form. So cosine theta plus I sine theta to the power of n, that can be written as cosine n theta plus I sine n theta, where I squared is equal to -1. So we need to show that this is true. I think I'm going to need a lot more space here, sorry. Right, so we need to first show it's true for n equals 1. So sub in n equals 1 here. So all to the power of 1 is equal cosine theta plus I sine theta. Tick, right? Is true for n equals 1. Now we assume true for n equals k. So cosine theta plus I sine theta all to the power of k is equal to cosine k theta plus I sine k theta. So we assume it's true. Remember that, we're going to need it. And now we're going to prove true for n equals k plus 1. So cosine theta plus I sine theta, the power of k plus 1, is equal to cosine k plus 1 theta plus I sine k plus 1 theta. K plus 1 theta. So I need to get my left-hand side to my right-hand side. Well, I'm going to use my rules of indices here. So I can rewrite this as cosine theta plus I sine theta times cosine theta plus I sine theta to the power of k. I'm going to use my assumption here, right, and replace this with cosine k theta plus I sine k theta. So cosine theta plus I sine theta times cosine k theta plus I sine k theta. Multiply this out. Cosine theta times cosine k theta is just cosine theta cosine k theta. Cosine theta times I sine k theta. That's going to be plus I cosine theta sine k theta. Then I sine theta times cosine be I sine theta cosine k theta. And then I sine theta times I sine k theta. I times I is -1. So this will be minus sine theta sine k theta. Right, so I expanded out my left-hand side. Now what I'm going to do is I'm going to gather my imaginary and real parts. So I have cosine theta, cosine k theta, minus sine theta, sine k theta, plus, I factor out the I here, cosine theta, sine k theta, plus sine theta cosine k theta. Now, what we do here is we're going to use a trig identity. So, if you recall the identity here, it is let me tell you, cosine A plus B is equal to cosine A cosine B minus sine A sine B. And that matches up here. So this actually simplifies to cosine theta plus k theta. And then this one here will simplify to, inside here, we're going to use sine A plus B is equal to cosine A sine B plus sine A cosine B. Right, and that makes sense here. So my A here being theta and my B here being k theta. So this actually simplifies to sine theta plus k theta. So I sine theta there. So my left-hand side now is cosine bracket, factor out a theta here. I'm left with k plus 1 theta after I factor out the theta, plus I sine, factor out the theta here, k plus 1 theta is equal to, and would you look at that, that actually does equal my right-hand side here. Therefore, by induction, we have proven de Moivre's theorem. So hopefully this video was some help to you guys. And you can see it well. Thanks so much for listening, and I'll catch you guys later. Bye.